For many unstable parent nuclei, the daughter product is itself radioactive. This gives rise to a radioactive series where there may be 10 or more different radioactive daughter products. The variation with time t of the percentage p of different nuclei in the radioactive sample is illustrated in figure 8.2. So the parent nuclei is a daughter nucleus, and in turn this daughter produces a further daughter. Initially, there are 1.2 times 10 to the power 15 nuclei of the parent isotope in the sample, and the daughter products are not present. The parent isotope has a half-life of 3 years, and the daughter product D has a half-life of 15 years, decaying to form further daughters S, which is stable. On figure 8.2, labeled with the letter S, the line representing the variation T of the number of nuclei of stable further daughter S. Give an explanation for your choice. So we choose S is the monotonically increasing graph. Okay, the reason is that since S is stable, its number should keep increasing as more D will decay to form S. State the time after which the daughter product D will have its maximum activity. So since A equals to lambda n, maximum activity is when the number of D is the largest. That is almost 9 years. So calculate the maximum activity in microcuries of the daughter product D, given that 1 microcurie equals to 3.7 times 10 to the power 4 becquerel. So A is lambda n. So they will give us the answer of 32.3 microcurie. Suggest why the number of nuclei of the daughter product D increases to a maximum and then decreases. The number of D at any time depends on two processes. One, the rate of production of D from P, and two, the rate of decay of D to form S. So initially, process 1 is greater than process 2, so D increases. Now when D is equal to 1, when the process 1 is the same as process 2, then D will reach a maximum. And when process 1 is less than process 2, D will decrease. The relative activities of the parent isotope and the daughter products may be used as a means of determining the age of the sample. Suggest why this technique may provide reliable results for ages up to 30 years, but for an age of about 100 years, the method would be far less reliable. For a period of 30 years, the percentage of parent nuclei will have dropped to almost zero, and the percent of nuclei of daughter product D will still be about 30%. The activity from the decay of D can still be determined rather reliably. For a period of 100 years, almost all D will have decayed to S. The activity of D decreases to a very low value, which is the most constant. Thus, the relative activity of the parent isotope and the daughter product D cannot be measured reliably. Therefore, the method would be far less reliable to determine an age for about 100 years.